Okay, hi there. So today I'm going to be teaching you guys about polar arc length. I just have a few papers here that are going to help us with learning the polar arc length, and I'm going to try to go through it. I've already pre-written them out, so hopefully that's helpful in teaching and learning. So I'm just going to jump right into it. So we're supposed to find the length of r is equal to e theta from 0 to 2 pi. So the first thing we need to know is the polar arc length formula. So the formula is considered from a to b, or alpha to beta, because we're dealing with angles, of the square root of f of theta squared plus f prime of theta squared, d theta. And don't forget the squared because that's really important, and we would get the wrong answer if we didn't. So think of finding arc length as a shoelace, because if you spread out a whole shoelace, if you go out to the whole length, then that's what we're trying to find, because we have a difficult time finding the length of a shoelace when it's all crinkled up, but we can make that easier with this formula by spreading it out and evaluating the whole length of the shoelace. That's like a little memorization tip that I use. I think it's pretty helpful. We'll see what you guys think. So first, I have our keys on the side that we need to follow. So our steps, we only have 4 here. Number 1 is think and evaluate. So what does that mean? That means that we need to think about our equations and what we know. So we think that, yes, we know the polar arc length is this formula right here. And we also need to know that our length of what we're finding is e to the theta from 0 to 2 pi. So you don't have to know what it looks like necessarily, but just know what you're dealing with. Know the derivative, know what, length you're finding from. So let's jump into it. So now we're going to move on to step 2, which is know your knowns. So our knowns are dr d theta is equal to e to the theta, because the derivative of e to the x, or e to the theta, or e to the anything is just e to the theta. So now we can know our knowns, which is also our formula, and plug into our formula. So that's obviously step 3. Plug in. So we know that we're evaluating from 0 to pi over 2, and we're going to plug in 0 to pi over 2 of the square root of e to the theta, which is our original, squared, plus our derivative, which is e to the theta squared d theta. Now, we're going to plug this stuff in and simplify it. So what we know is that if we simplify this, it's going to be the integral of 0 to pi over 2 of the square root of e to the 2 theta plus e to the 2 theta. We just distributed in the square, and we're done with simplification. Now, to evaluate, we're going to plug in 0 and pi over 2 for each. So our formula is f of b minus f of a for evaluating integrals. So we're going to take the square root of e to the 2 times pi over 2 plus e times 2 pi over 2. We're going to combine those minus the square root of e to the 2 times 0 plus e to the 2 times 0. And once we simplify, we just know that the 2's cancel out for quick math, so we're just left with pi. So our simplified formula is the square root of e to the pi plus e to the pi minus 1 plus 1, which is the square root of 2. So stop here. Don't go any further, because if we even simplify any more, we're just going to get ourselves confused, because normally math and calculus and arithmetic don't go together. So just keep your calculus, keep what you know. The AP graders will know. This will save you a lot of time and headaches as well, because for me, I can't do basic arithmetic. So just stop, don't go any further, and just finish off with your step 4. Make sure you conclude, because the graders like that, and sometimes your teacher will like that. And I conclude that the polar arc length of r is equal to e to the theta is the square root of 2e to the pi minus the square root of 2. And that's it. That's all we have to do. So that was pretty easy for step 1, or example 1, I should say. And hopefully that seemed pretty simple. We're going to move on to a couple more problems just to illustrate some more and go into more of maybe difficult problems to solve. So here we go. So we're supposed to find the arc length of r is equal to 1 plus cosine of theta from pi over 2 to pi. So we're going to do our steps. So our think is, here we go. We have a graph that we know the area, or what it looks like, what the graph looks like of pi to 0, or 0 to pi, of 1 plus cosine of theta. So it's a big loop, but essentially all we're finding right now is this little piece right here in quadrant 2. So know our knowns. So the derivative of r dr d theta is going to be equal to sine of theta, because 1 plus cosine of theta is sine, because 1 drops away because it is a constant. Now, let's plug in our knowns into our equation. So from pi over 2 to pi for our a and b of the square root of our original r, or f of theta, 1 plus cosine of theta squared, plus our derivative sine of theta squared d theta. Now, let's plug into the equation our areas of where we're supposed to find. So we're going to plug in pi and pi over 2, and you might need to know a little bit of trig, so make sure you know your background of trig. So cosine at pi is -1, sine at pi is 0, cosine at pi over 2 is 0, and sine at pi over 2 is 1. So I'm going to show you this on the calculator because this is kind of a big problem and they can get a little scary. So I'm going to show you how to work the calculator as well. So if you have a TI Nspire, these are pretty easy to use and they're very user friendly. So you just go to add to calculator, and then you have this handy little button here on the side. It's down here by the delete button, and you can click it, and they give you all kinds of formulas for whatever to use, but I'm going to use this one down at the bottom that's highlighted in blue. That's the integral one. So I'm going to choose that, and then it lets you plug in everything you need to plug in. So right now, we're plugging in for pi over 2 for our limits, pi over 2 to pi of the square root, oops, didn't mean to push that, of the square root of our formula. So 1, make sure you have parentheses, that's very helpful. 1 plus cosine of theta squared plus sine of theta, all in parentheses, squared, d theta. Don't forget that one either. So once we have that plugged in and we have all our parentheses, I also double check whether to see if we have enough parentheses and if everything's bracketed off okay, because that can create issues sometimes. So it looks good, so I'm going to click enter and see what my answer is. Oh, look, 1.1715. So that'll be our answer for this problem. That's the arc length of 1 plus cosine of theta. And look, we already have that down here written for us. So we're going to finish this and conclude that the arc length of r is equal to 1 plus cosine of theta from pi over 2 to pi is 1.1715. You could put units or you can just leave it. They really don't care, just as long as you have the answer to it. So all of the calculus BC material are very difficult to memorize, so I have a little bit of memorization tips here. So when you memorize something, just try to make it meaningful. Make your lessons meaningful. Don't go through the motions. Make it meaningful to you, because I know that you probably deserve this qualifying exam score, and so do I. So I always try to make it really meaningful for me, and I try to think of little devices that I can use to help me memorize the formulas, because you can get into 6, 7, or 8 formulas and you're like, oh my gosh, which is which? Because that's definitely me. So Mr. Arthur has had us make little flashcards, and they're different colors, as you can see. So we have green, orange, pink, yellow, whatever. And we just go through these in class every day. Just flip through them, make whatever you're learning onto these flashcards. And even you can do this at home. So, obviously I have one for polar arc length, and I just flip it over. Oh, and I see, there's the equation that I need to know. Quiz your friends, quiz yourself, have your mom and dad read them off to you, whatever you do. Just try to memorize them, because that's probably been one of my biggest mistakes, is not taking enough time to do that. Just do that, because it'll be very beneficial to you, because now I'm trying to scramble to memorize things, and it's tough. So make it meaningful. So here's some little meaningful tips for you that I've come up with. They might be a little stupid, but they're kind of fun, I think. So to remember the polar arc length, I remember the sentence, I pulverized, haha, for polar, that equation, because the square root of r squared plus r prime squared is easy. That is so easy to do. So I don't know, maybe that's kind of corny. Or I do, think of a polar bear on a square of ice, wondering how big his square is. Maybe that might help, I don't know. Maybe it'll connect the polar equation with the word polar, so maybe you can figure out which is which. And here's an acronym. I like to use acronyms. I said to run and to drive. So that means that we're going to integrate the square root of r squared for run to plus dr, which is our drive, squared. So I don't know, maybe that'll help. And then I found online just a little fun bit where they said just do it, and I think that's funny. It's kind of cute. But otherwise, I wish you luck on the test, and hopefully you can remember the polar arc length, and hopefully this video has been helpful. I wish you the best, and good luck. Thank you.